Hi. So this is the continuation of our lesson. Last time we covered EOQ, Economic Order Quantity. Ito yung pinaka-classic na model for valuation of the optimal quantity orders. We dealt with the costs associated with inventory, if you could remember that time. The total cost of inventory is composed of the total carrying cost or holding cost, and at the same time the total ordering cost, and the relationships that exist between the two. Today, I will cover some of the extensions of the model. They are very similar models, very similar to EOQ. And today, as you can see in the board, it's called the economic production quantity. So, anong difference ng economic production quantity? I would like to apologize if my audio and my production is not as good because I'm just using my handheld device. Pagtsagaan nyo na lang muna pag nakabili ako ng mas magandang mic. Okay, so you're looking at the book, and there's a graph that shows the behavior of the total cost. Very similar to EOQ. But what's the difference of economic production quantity? Walang masyadong malaking difference. The only difference is that this is dealing with production in batches. Yung EOQ kasi is ordering, when you order from a vendor. Ito namang model na ito is when a company is producing in batches, meaning that inventory is, nabubuo yung inventory through production. Okay? Now, this works with companies that deal with work in processes na ginagamit nila for production. Okay? Now, ang behavior kasi ng inventory under economic production quantity or EPQ is that usually yung production is continuous na nangyayari. Therefore, the increase in inventory is almost in a continuous flow. Unlike sa EOQ na nag-place ka ng order at dadating yung order at a particular time, so biglang taas agad yung inventory mo. Sa EPQ, hindi ganon. Continuous yung increase ng quantity ng inventory, pero nababawasan din yung inventory because of usage. And the maximum amount of inventory is reached as hanggang tumigil ang operations mo or hanggang tumigil ang pag-produce mo. Okay? I hope that's clear. The same assumptions are followed, katulad din sa EOQ, except that orders are received incrementally instead on a single delivery. So if you look at your book, makakakita kayo ng assumptions ng EOQ at assumptions ng EPQ. Parehas na parehas lang yun. Ang difference ng assumption dito ay orders are received incrementally instead of a single delivery. Now, if you look at the formula, let's look at the formula na ha. Next slide, please. Ito yung sinasabi kong assumptions, no? Okay. The number 5 assumption is what makes EPQ unique. The production rate is constant when the production is occurring. Yun lang yung pinagkaiba niya sa EOQ. Okay? So let me move on to the next slide. Okay, now it's the total cost. How do we compute for the total cost of maintaining inventory under EPQ model? If you notice, it's the same. Carrying cost plus setup cost. It's almost the same. Diba yung dati, it's carrying cost plus ordering cost. This time, it's carrying cost plus setup cost kasi hindi ka naman umu-order. Diba nagpo-produce ka nga. And when you produce items, you have to deal with costs like pagbabago ng setup, clean up, and all of those things. So those things are called setup costs. Okay? So this is the formula. Now, if you notice, carrying cost is equal to IMAX, or the highest level of inventory that was reached through production, divided by 2 times H plus DO over Q times S. Parehas din lang yan. Ang pinakaiba lang, IMAX ang ginamit dito kasi nga nagpo-produce ka, hindi ka nag-iintay ng dating ng delivery. IMAX is referring to maximum inventory divided by 2. So, essentially, IMAX over 2 is equal to your average inventory. Okay, let's move on to the next slide. Now, the economic order quantity follows this formula. It is still the square root of 2ds over h multiplied by the square root of p over p minus u. Now, you are now introduced to new variables, namely P, or production or delivery rate, and U, which is usage rate. Madali lang naman ito. All you have to do is to plug in the values sa ating formula. Now, you just have to remember that the unit of measure of P and U must be the same for the model to work. Okay? So, you might be needing a scientific calculator for this. This is called the QP, or the economic production quantity. Economic production quantity, or QP. Now, another variable that I might ask you to compute is cycle time. Let's define first what cycle time. Cycle time is the time between setups and consecutive runs for the economic run size model. So, cycle time has the formula of QP divided by U. Okay? Cycle time. Lead time yan. Next is run time. Run time is the formula of QP over P. So, what is the run time? The run time is the production phase of the cycle, which is a function of both the run lot size and the production rate. If you look at the formula, it's yun yung optimal quantity of production in units, or optimal run quantity divided by your production or delivery rate will lead you to run time. Okay? Next. So this is a sample problem given to us by the book. I'm not sure if this is the same discussion that was written in your text, because I'm using the 13th edition of the book. So I want you to just silently read on this and be familiar with the given in the problem. And at the bottom, you will notice that there are questions like, what is the optimal run size, maximum total annual cost for carrying and setup, cycle time for the optimal run size, and the run time. All of these things, nabigay ko na yung formula kanina. Okay? Ulitin ko, all you have to do is just to use the formula and plug in the values as you read and identify them in the problem set. So if you remember your math during your high school, it would help if you would identify the variables and write the given in your solution sheet. Okay? So in this particular case, tingnan nyo dito sa book nyo, pag nabasa nyo yung problem, it helps if you write your given. Your annual demand per year is 48,000. Your S, which is, what is S again? S is the setup cost. It's $45 per setup. H is the carrying cost per unit. Carrying cost per unit. Problems, it depends. Sometimes the carrying cost is stated as a dollar value or a peso value per unit. But sometimes carrying cost is a percentage of the unit selling price. So tingnan nyo na lang sa problem kung ano ang given doon. Pero parehas lang naman. P, which is referred to as the production or delivery rate per run, is at the rate of 800 wheels per day. Again, what is P? Yun yung napoproduce na wheels per setup or per run, 800. Okay, so what you have to do is, if you simply follow the procedure, know the formula, and plug in the values as stated here. Okay, so therefore our economic production quantity given the formula and after plugging the values is at 2,400 wheels. Now the total carrying costs, the minimum total carrying cost. Bakit TC minimum ang nakasulat dyan? TC min. Anong ibig sabihin ng min? Essentially, if we are producing at economic production quantity, ibig sabihin, yun na talaga yung quantity that will yield to the lowest cost. That is why the total cost min is stated as carrying cost plus setup cost. In other words, let me repeat, if you are producing at EPQ, it also follows that you are producing with the least and optimal level of cost estimation. So, carrying cost plus setup cost is equal to I max over 2 times H plus D over DQ P times S. Okay? So, yan yung procedure. I just want you to look at it for a while. Okay? Go ahead and check it out. Madali lang yan. Okay? Again, pag medyo nahihirapan, pwede nyo itong i-pause and refer to your book. Okay, let's move on. So, this is the computations na hinihingi dun sa problem. Again, di ba kanina hinihingi ay cycle time for the optimal run size and the run time. So, this is the formula for cycle time, QP over U, and run time is QP over P. Take note of the explanations. What does it mean? Ano ibig sabihin ng cycle time? In this particular case, the cycle time is 12 days. Time, ang hinihingi, therefore, measure of time ang sagot dyan dapat, 12 days. Thus, a run of 12 wheels will be made every 12 days. Sa run time naman is, ibig sabihin, each run will require 3 days to complete. Ganun katagal ang isang production run at the level of economic run quantity. Okay? Try to absorb it. Next. Okay. First, discounts. How do we compute for the total cost of maintaining the inventory if there is discounts involved? We are normally faced with situations wherein our vendors would offer customers to induce them to buy in large quantities by offering discounts, no? So, in other words, let's extend the formula by allowing discounts to affect our decision. So, may extend uli natin yung ating formula. This time, paano kung may discount na ino-offer? So, if you notice, nadagdagan na naman tayo ng isang element sa ating formula. Q over 2 over H is your carrying cost. D over Q times S is your ordering cost. But this time, may napadagdag. And napadagdag is plus a purchase discount. The behavior of purchase discount is discussed in figure 3.7, wherein the total cost with purchase discount is naturally increasing because of the element which is PD. So, I don't want to reiterate on that further kasi baka malito lang kayo. Let me go straight to the problem. Okay? So, ganito na yan. So, this is the problem set. Ang procedure for computing the total cost or the optimal quantity with discount is shown here. Now, given is the problem, the maintenance department of a large hospital uses blah blah blah. I want you to take a read. In other words, read this problem set. Okay. So what are the steps? The first is to compute the common minimum quantity, or what we call Q. Well, yung libro kasi nagpapalit-palit siya kuminsan ng term. Sometimes it ginagamit ng libro is economic order quantity. In this particular set, ang ginamit niya ay common minimum quantity, or pagka sa batch production, ang ginagamit niya ay economic run quantity. It's all the same. It means the same. Like, in this particular case, the first step is compute for the common minimum quantity. If you notice, our formula is the same as the EOQ formula. Square root of 2 ds over h. So therefore, our answer is 69.97 is equal to 70 cases. Okay. I want you to always run I want you to what do you call that? Round off your answer to the nearest whole number, because we're dealing with inventory. There's no such thing as 69.97 inventory. You always have to refer to a whole number because we're dealing with inventory, non-integer values. Okay? So na-compute na natin ang EOQ given the information. So what makes it different is steps numbers 2 and 3. Let me continue. Okay. Now, in this particular case, okay, while the EOQ is 69.97 or 70 cases, the second question is, how much is the total cost at EOQ? At EOQ, which is 70 cases. Ganun pa rin yung ating formula. But, dinagdag lang natin yung purchase cost. Pinlog in lang natin yung purchase cost sa ating equation. Okay? Now, if you notice, in-extend din natin ang ating computation sa 80. Bakit kaya? It is because 80 is the start. Oh, by the way, let me go back. Our answer here is the total cost of maintaining 70 cases of inventory is 14,968. How did we get to that? Q is 70 divided by 2 times 4 plus 816 over 70 times 12. These are things given in the problem. I just want you to take note of this last part. 18 times 816. Right? The selling price or the cases can be bought at 18 per case multiplied by the D. And how did we get to D? 816. It's the total cost to purchase is 816 a year at the rate of 70 cases per order. 18, tama ba ako? Tama, 18. Tingnan nyo yung 70, 70 cases can be bought at 18 per case. How did we know that it's 18 per case? Usually, binibigay sa problem, Tama. Kung 80 yung sagot, or, 70 yung sagot, 70 falls under 50 to 79 range. And the price is at 18. So, yun ang gagamitin natin doon. Kaya ginamit natin ang 18 times 816 cases. Okay? Okay. Para kasing sensitivity analysis ito, tingnan nyo. The next is we will compute at total cost at 80. Why 80? Bakit 80 naman yung sunod nating kinompute? Check this out. 80 is actually the start of a range that will yield a lower cost of 17. Let me repeat. 80 is the start of the range that will yield to the the price of 17. So we want to check that out kasi pababa na yan, so 80. So the total cost to order 80, or minimum order of 80 to take advantage of 17 is actually 14,154. See the difference? We are changing the quantity to 80 and at the same time, instead of 18, we're down to 17 kasi bumaba na nga yung purchase cost based on the range. Okay? Now, bumaba na siya sa 14,154. And then the last computation is total cost at 100. Again, why 100? If you look at the range, 100 is the start of the quantity that yields to a price of 16. We want to check out if, in case we want to hit 100, are we saving on cost? So, 100, let's see 100. We will use 100 this time. All the Qs will be replaced by 100, but this time, it's no longer 17, but it is now down to 16 times 816 is equal to 13,354. So what have you noticed? The cost has dramatically increased to 13,354. Therefore, look at this problem set. Because 100 cases per order yields the lowest total cost, 100 cases is the overall order optimal quantity. Gets? Ganun lang naman yun. So, that's the how to deal with computing for the total cost when quantity orders are factored in. Okay. Another thing that we need to compute is what we call the ROP. What is ROP again? Let me just check the book. ROP is referring to reorder point ordering. So the definition is, its reorder point is when the quantity on hand of an item drops to this amount, the item is reordered. So at what amount do we need to place our order? So napakadali na lang ng formula na niyan. We can use this formula if the following assumptions are existing. And if it does exist, then the following is ROP is equal to D over lead time, which means demand rate, units per day or week, over the lead time in days or weeks. So ROP, that's the formula. Remember that because you just simply have to factor that in. Okay, that's about it for my lesson. That's already 22 minutes, so hanggang dito na muna lang. I'll be uploading an exam or at least a quiz later on for your exercise. Thank you so much. Bye.